Good morning, everyone. Today we are going to discuss about some physical properties of alcohols and phenols and chemical properties. Okay, right. Now see here. Alcohols. Here I have taken ethyl alcohol. Ethyl alcohol isomeric functional which is exhibit the isomeric functional group isomerism with the ethers. Functional group isomeric with the ethers. So now you see here, when these two compounds of molecular formula, these two compounds molecular formula same only, but it will become a difference in the boiling point. Why? Because you see here, ethyl alcohol exhibit the hydrogen bond. What type of hydrogen bond you know? Intermolecular hydrogen bond. Intermolecular hydrogen bond. Okay. Why? Because oxygen has hydrogen. Oxygen has the hydrogen. Ether's boiling point is lower than alcohols. Alcohol boiling point higher than ethers. Why? Because these alcohols are formation of intermolecular hydrogen bond. Why? Because oxygen are having a hydrogen, but in ethers there is no hydrogen in oxygen. But ethers there is no hydrogen in oxygen. Okay, so you see here, due to this reason, alcohol's boiling point higher than ethers. You remember? Okay. Now see here. Now we discuss about the solubility of alcohols. Solubility of alcohols. See, in the solubility of alcohols, lower alcohols are more soluble than higher alcohols. What is that, you know? Lower alcohols more soluble than higher alcohols. Higher alcohols. These all alcohols are liquid in nature only. All alcohols are liquid in nature only. Okay, so lower alcohols are more soluble than higher alcohols. Sir, why? Because you know, if you compare the two alcohols, for example, I am taking here ethanol, and here I am taking like hexanol. See, these are the lower alcohols. So these are the higher alcohols. In these two alcohols, lower alcohols are more soluble in water than higher alcohols. Why? Because higher alcohols, large non-polar hydrocarbon bond. This word is important, you know. I am telling you know, higher alcohol having the large non-polar hydrocarbon part. Large non-polar hydrocarbon part. So that's why higher alcohols are less soluble in the water. Okay, right. Now see, the important point you remember, this is the important thing. We compare the alcohols and phenols. We compare alcohols and phenol, both are liquid in state only, but having same functional group OH only, but OH which is present in alcohol OH which is present in means attached on benzene ring, which is act as a phenolic group. Okay, now see here. Please now you observe these two compounds. In these two compounds, it has OH group is directly attached to the phenol benzene ring. So it has a phenolic functional group. Phenolic functional group. Here OH is attached to the CH2 group. This is alcoholic functional group. Okay. For example, if they ask, these two compounds are exhibiting what type of isomerism means? These two are exhibiting only functional group isomerism only. Maybe you have the doubt. Sir, where is the functional group is changed? Here OH, here also OH is there. So where is the functional group? OH not changed. Actually, functional group isomerism means one functional group is changes into the another functional group without changing the molecular formula. But here is the here OH only, here OH. But you see, these two are exhibiting the functional group isomerism only. Why? Because here OH is directly attached to benzene ring. This is phenolic functional group. Here OH is attached to the CH2 group, here alcoholic functional group. So that's why these two are exhibiting functional group isomerism only. Functional group isomerism only. Functional group isomerism only. Okay, just to remember this. Next, you see, if we compare the acidic nature of alcohols. Acidic nature of alcohols. Okay, this topic is very, very important. The acidic nature of alcohols, because now see here, first of all, I am taking CH3CH2OH. Ethanol is reaction with sodium metal. Ethanol is reaction with sodium metal. Okay. So here hydrogen is attached to oxygen. So sodium metal, which can replace the hydrogen from ethyl alcohol, then formation of sodium ethoxide and liberate the hydrogen gas. Okay, right. Now see, by this reaction, we can say that alcohols are having acidic nature. But how much percentage acidic nature? If we compare with other alcohols, otherwise if we compare with the phenols, how much percentage acidic nature is there? Okay, that we'll discuss now. Okay, so that's why now I am telling you, see, for example, the same ethanol, if you take the sodium hydroxide, NaOH, there is no reaction. No reaction at all. There is no reaction. Because sodium hydroxide, strong base, very strong base. Strong base maximum reaction with the strong acids only. It means the sodium hydroxide unable to reaction with these alcohols means those alcohol not that much of acidic power, the acidic nature. So that's why we can compare alcohols are low acidic nature only. Right. Next you see now we will compare acidic nature of primary secondary tertiary alcohols. Now here I am taking, see, ethanol, this is a primary alcohol, and I am taking secondary alcohol and tertiary alcohol I am taking. See, primary alcohol, secondary alcohol, and tertiary alcohol. 3 alcohols I have taken. Now see, in this 3 alcohol, which of the following is more acidic in nature? More acidic in nature. Now you remember, primary alcohols are more acidic in nature. Primary alcohols, order of acidic nature. Order of acidic nature. Okay, order of acidic nature, which is primary alcohol more acidic nature, then secondary, then tertiary. Primary greater than, secondary greater than, tertiary. So why you see here? 3 methyl groups are which can donate the electron to carbon. The carbon which can donate the electrons to oxygen. Then oxygen power of electronegativity increases, which can hold the hydrogen. So hydrogen from here it is unable to remove, unable to liberate. So that's why tertiary alcohols are weak acid when compared to secondary and primary. So here 2 groups are there, 2 CH3 groups are there. Increase the electron density than oxygen. So oxygen power increases, which can hold the hydrogen. So if it is hydrogen liberates, so that is more acidic. But here hydrogen not liberating outside, so that's why less acidic compared to primary. So that's why you remember the acidic nature order of alcohols, primary greater than, secondary greater than, tertiary. You remember this point. You remember this point. Now see, this acidic nature, now we'll compare with this acidic nature will compare with the in between ethanol and phenol. Ethanol and phenol. What is this? This is the ethanol. What is this? This is the phenol. If you compare this acidic nature in between ethanol and phenols, question they will ask like this. In between alcohol, ethanol and phenol, which are the following more acidic? Give you a reason. They will ask like this. Okay, now you remember, your answer is that phenol is more acidic than ethanol. Phenol is more acidic than ethanol. Why? Because now see, from here, if it is proton is liberated, then this phenoxide ion it will be formed. When proton from alcohol is liberated, then ethoxide ion is formed. Okay, so this phenoxide ion is more stabilized due to resonance. This phenoxide ion more stabilized due to resonance compared to ethoxide ion. Okay, you got this point? So now you see, now what I'm telling you now, phenoxide ion more resonance stabilized than ethoxide ion. More resonance, phenoxide ion is more resonance stabilized. Resonance stabilized than ethoxide ion. More resonance stabilized than ethoxide ion. Okay, so due to this reason, phenols are more acidic than ethanols. You remember this point. Okay. Now see, in this phenols only, if you compare in this phenol only, if you compare phenol orthonitrophenol, methanitrophenol, and paranitrophenol. So this is phenol, orthonitrophenol, methanitrophenol, okay, and paranitrophenol. If you compare acidic nature of these four compounds, which are the following? Okay, which are the following more acid? For example, four options given: option number 1, option number 2, option number 3, option number 4. Four options given for you. So among these four compounds, which are the following is more acidic? You remember, among these four compounds, more acidic, to remember the one technique you remember, there is a phenol. You remember, what is this? Phenol. First, paranitrophenol is more acidic nature. Thereafter, orthonitrophenol, then meta, then phenol. See, one point to remember here, when electron withdrawing groups, present on benzene, acidic nature increases. When electron withdrawing groups are present on benzene, acidic nature is increases. But because electron withdraws, oxygen electron negativity is decreases, then automatically the hydrogen it will be liberated from that. So then it is act as a more acidic nature. So if you want to write the acidic nature of these compounds, more acidic is fourth compound, then after second compound, then after third compound, then after first compound. So this is the order of alcohols. Remember, they are given four compounds. The technique is that phenol, para, ortho, meta, and phenols. Okay, right. Next, so for example, electron donating groups present, then what happens, sir? Electron donating groups present, then what happens, sir? That is also we'll see. Now here also, again I am taking phenol and benzene OHCH3. And benzene OHCH3, these two groups are present, what is called, cresol. What is it called? Cresol. So this is orthocresol. This is phenol. This is orthocresol. Okay, right. This is metacresol. Okay, this is paracresol. Phenol, orthocresol, metacresol, and paracresol. So among these four compounds, which of the following is more acidic? Which of the following is more acidic? Now see, electron donating groups are present. Electron donating groups are present. Oxygen electron negativity is increases. Then oxygen electron negativity is increases, which can hold the hydrogen, not liberate. Okay, got this point. So that's why here you remember, compared to all, phenol is more acidic. This is the compound 1, compound 2, compound 3, and compound 4. Phenol is more acidic. Phenol is more acidic. Phenol is more acidic. Phenol is more acidic. Then after comparing this one, you remember, after metacresol is more. So thereafter, paracresol and orthocresol maximum same. Both are same acidic nature. Okay, if you compare, then ortho, then para. Actually, these are equal only, but very minute. The ortho is little greater than that. Okay, so you remember. So whenever according to our NCERT textbook, orthocresol and paracresol acidic nature is equal, same only. Okay, but some other book they are given just little minor. Okay, this acidic nature is higher of orthocresol than para. Okay, now see the another important compound I am telling here. See, whenever you compare carboxylic acid and phenol, which of the following is more acidic? No doubt at all. You know, I forgot to tell you the important point. Phenol, common name, carbolic acid. Carbolic acid. Don't get confused. Methanol is called carbinol. Methanol is called carbinol. Phenol is called carbolic acid. This is acetic acid. This is acetic acid. But you remember, whenever in the subject, whenever we are talking about the acetic acid, we consider as it is weak acid, weak acid, weak acid, we consider like that. Okay. So, but you remember that whenever you compare with the phenol and the carboxylic acid, whenever you are compared with the phenol and the carboxylic acids, carboxylic acid is more acidic than phenol. You remember, phenol pKa value is 10. Carboxylic acid pKa value 3.76. It will be. Then you see how much acidic nature of carboxylic acid than phenol. So that's why you remember phenols are less acidic nature than carboxylic acid or ethanoic acid. Or ethanoic acid is more acidic than phenols. You remember this point. Okay, right. Now see, I'm going to introduce the very important compound, that is picric acid. And benzene OH, NO2, NO2, NO. So this is called picric acid. Picric acid. Picric acid. IUPAC nomenclature 2, 4, 6. Trinitrophenol. IUPAC nomenclature 2, 4, 6. Trinitrophenol. So this compound, very powerful acid, strong acid. Then remaining what we are discussing: orthonitrophenol, paranitrophenol, metanitrophenol, orthocresol, metacresol, paracresol, phenol, carboxylic acid, ethanol. Compared to these all compounds, still now what I have written? This picric acid is a powerful acid. You remember, very powerful acid. Okay, right. So by taking one question, you are able to recognize the answer of acidic nature. Option A, phenol. Option B, parachlorophenol. Option C, paracresol. Option D, orthonitrophenol. In the given 4 options, if they ask which of the following is least acidic, Which of the following is least acidic? Now see, which of the following is least acidic? Okay. Now in the 4 compound, electron donating groups are present, that is act as a least acid. So option C, least. If the same question if they ask which of the following strong acid, electron withdrawing groups are there, that is the strong acid. So then after D. So this is chlorine electron donating group or withdrawing group. That point to remember. When which is attached to the phenolic compound, chlorine acts as a electron withdrawing group only. Electron withdrawing group only. You remember this point. Okay. So that's why here this is also withdrawing group. If you want to write the order of acidic nature, order of acidic nature, then on the all strongest acid is D1, then after B, then after A, then after C. So this is the order of acidic nature of given compounds. Okay, right. Now we discuss about the chemical properties of. Now we'll discuss about the chemical properties of alcohols. Chemical properties of alcohols. Okay. See, in the chemical properties of alcohols, the important point is that the reactions alcohols, for example, you see here I am taking ethanol. This is ethanol. The chemical properties involved in the participation of alcohol, carbon to oxygen cleavage reactions are there. Okay, and oxygen to hydrogen cleavage reaction is there, and whole alcohol molecules, whole alcohol molecules involved in the reaction. So these alcohols, 3 types of reactions are participate. One is the carbon to oxygen cleavage reactions, oxygen to hydrogen. You see, this is first one. So this is second one. Oxygen to hydrogen cleavage reaction is there. Carbon to oxygen cleavage reactions are there, and all molecules participate in the reactions. These 3 types of reactions are participate. So what I am telling here the very special and important point is there. Whenever carbon to oxygen cleavage, we have now, for example, 3 types of alcohols are there. Primary alcohol, secondary alcohol, tertiary alcohol, like this. 3 types of alcohols are there. So in the 3 types of alcohols, primary alcohol, secondary alcohol, tertiary alcohol, like that. So if carbon to oxygen cleavage reactions, tertiary alcohol participate first, then secondary, then primary. You remember these orders are very important. For example, oxygen to hydrogen cleavage reactions are there. The reactivity order primary greater than secondary greater than tertiary. Okay. And for example, whole molecule involved in reactions are there. So that is a tertiary greater than secondary greater than primary. You remember, this is the order of reactions. Okay. Here, both type of reactions I will explain you. One is CO bond cleavage reaction. One is OH bond cleavage reaction. Both reactions I will show you. That is now here I am taking esterification reaction. Esterification reaction. Ethanol CH3CH2OH is a reaction with the ethanoic acid. Ethanol reaction with the ethanoic acid. So this reaction takes place in the presence of concentration. You remember esterification reaction. This is the from carboxylic acid, carbon to oxygen bond cleavage, but from alcohol, oxygen to hydrogen bond cleavage. So esterification reaction is the best example for the oxygen to hydrogen cleavage reaction. So if the alcohols are primary, secondary, tertiary alcohols are involved, primary alcohol participate in esterification reaction fast. You got the point? Oxygen to hydrogen bond break in esterification reaction. So here primary, secondary, tertiary in 3 alcohols. In esterification reaction, primary alcohols are reacting more than secondary, then tertiary. Okay. So here carbon to oxygen cleavage reaction order, tertiary greater than secondary greater than primary. So for that also I am taking one example. For example, these alcohols reaction with the hydrogen iodide, HI. So here what happened, carbon to oxygen bond cleavage, then what eliminate from here? So then formation of ethyl iodide, CH3CH to ethyl iodide. Now see, so carbon to oxygen bond cleavage takes place. The reactivity order of alcohols is tertiary greater than, secondary greater than primary. Okay, so till now just you remember. So remaining some chemical properties and very important physical chemical properties of alcohols and phenols we'll discuss tomorrow. Okay, thank you. Bye.